Hi guys, in this video I'm going to discuss parametrization for a line segment. Now there is a difference here as opposed to the whole line. So the whole line extends in both directions infinitely, right? But line segment, and in this particular case we have a directed line segment, meaning that there is a starting point. So the segment is supposed to start at the point P with coordinates -2, -5, 4, and then it's supposed to extend to Q with coordinates -1, 1, and -4. So there is a difference that it's not the whole line, but just the piece that connects point P and point Q. Okay? All right, so the easiest thing, first of all, is to go ahead and write down the vector that connects PQ, because we're going to need that. And as you know, we're supposed to subtract the coordinates of P from coordinates of Q. So we're going to start with Q and subtract coordinates of P from Q. Okay. So I'm just carefully documenting it. And then we have -4, subtract 4. So that will give me -1 plus 2. So that's 1. 1 plus 5 is 6. And then -8, right? Okay, so we can go ahead and put that here. That is 1, 6, -8. And I'm using the vector brackets. I could have used them from here, but you can also use the less than and more than sign. Then what you want to do is, how about the parametrization? Now, here is the problem. If I told you, give me the parametrization for a line segment that connects P and Q, that question has infinitely many different answers. Because when you're talking about parametrization, you are introducing a parameter. And the easiest thing to do is to think of this parameter as time that goes by. Well, time is not necessarily measured in hours or days or minutes or seconds or milliseconds or who knows what. You can count time from 8 a.m. today, or you can count time from 0 a.m. last night, or whatever. There are a million, literally infinitely many different parameterizations depending on how you define this time, okay? So when we say standard, we're just saying, okay, at time 0, it is supposed to be P, and at time Q, and at time 1, it's supposed to be Q. Okay, so that's my requirement. Otherwise, there is actually infinitely many different answers here. All right, so let's go ahead and figure this out. So we got x of t, y of t, z of t. So remember, when time is 0, we're supposed to get P. Well, P has coordinates -2, -5, and +4. So that's going to go in here. Okay? And then any line or line segment can never have anything other than number t. Number t. Okay? That's it. That's it. So what is that in the blanks? So some people saying, well, we just could put Q in there. Okay, well, if you put that, well, let me just for a second mess this up and put it there. What we want is at time 1, whether it's hour, whatever, at time 1, we're supposed to get Q. But if you substitute t equal 1, you would get -3. You're not going to get -1, right? So that does not work. So you have to delete that. Okay, what works is substituting the components that we got from vector PQ that connects P and Q. Those are the numbers that would go in the blanks over here. And you should always check that. If you substitute t equal 1, do you get point Q? Well, -2 plus 1 is at -1? Yes. -5 plus 6 is at 1? Yes. 4 minus 8 is at -4? Absolutely. So this is correct. Okay. Again, this is just a standard parameterization. There may be 1,000 different ones. It doesn't have to be at t equals 0 at P. Maybe it'll be at t equal 216 at P. I mean, it it depends, right? Well, how does t change? Well, because we said that 0 it's at P and at 1 it's at Q, then t is going to change between 0 and 1.